Spring break is almost here, right? Not a moment too soon, right? Too soon? Yeah, I don't know. I mean, I really do not mind at all that it is coming up so quickly. Seems really early this year. Um, Maybe we can, all go home before mumps spread around campus again. So, all right. So, first off, I have given you homework. I don't I account for the amount of work I expect you to do over spring break, which is precisely 0. So the due date kind of it does seem like there's a long due date, but that's because I skip over spring break. It is an easier assignment that tackles a lot of the things we've been going over, like while loops and strings and iterating over strings and indices in strings. So basically this Pig Latin assignment does test your mastery of strings. Be sure to follow the directions exactly, because if you try to show me something that does not use functions and does not actually do what I want and, can't follow the things that I have on the first page, you're going to have to redo it, which is no fun. So be sure to follow that. Today we're going to work on the Collat sequence, and then we're going to work on we'll either expand on working on the Collat sequence and talk about lists a bit, or we'll talk about using probably keep it where it is for the Collat sequence. And then what we'll do is we'll move on to one of the exercises in the book just to get some practice with lists and statistics and stuff. Let's see. So to review the Collat sequence, or the Collat's conjecture is basically this unproven assertion. I don't know why that's not working. 1 second. It's this unproven assertion that the internet at Temple really needs some work. Come on. All right. Turn off. Turn on. I'm sure you can play nice. Wi-Fi connecting. There we go. So the Collat's conjecture is that basically choose any number, any positive integer. If it's even, double it. It's not even. If it's even, divide by 2. If it's odd, triple it and add 1. So the conjecture is no matter what we do, no matter what number we start at, we're always going to hit 1. Right? That's the idea. No matter what integer we choose for n, we always get back to 1. Was introduced in 1937. And it's just, Paul Erdos said about the Collat's conjecture, and mathematics may not be ready for such problems. Paul Erdos was one of the most prolific mathematicians of all time. He had, he was known for both his social practice of mathematics. He engaged with more than 500 collaborators, and his eccentric lifestyle. He devoted his waking hours to mathematics, even in his later years. Indeed, his death only came after he solved a geometry problem at a conference in Warsaw. So he was really a math fanatic. He published around 1,500 papers. And in fact, the mathematicians have their own version of the Bacon number, which is the Erdos number, which is the distance, the steps in shortest path between a mathematician and Erdos in co-authorship. So if you've co-authored with Erdos, you have an Erdos number of 1. If you've co-authored with somebody who co-authored with Erdos, you have an Erdos number of 2. If you co-author with someone who has an Erdos number of 2, you have an Erdos number of 3, and so on. I have an Erdos number of 5, so which is rather average apparently. So, of course, if you have an Erdos, it is possible to have an Erdos-Bacon number, which is the lower of your Erdos number and your Bacon number. Sorry, no, the higher of your Erdos number and your Bacon number. So there you go. So the Erdos. So anyway, Erdos did not believe that this problem was really solvable, and it's very difficult. But what we can do is we can kind of we can compute some interesting things, which is we can write a basic function that will tell us, since this does say that all the numbers eventually hit 1, we can write an algorithm that basically asks how many steps does it take to get to 1. So let's go ahead and write that. I'm going to go ahead and create a document. By the way, your exams, they're about like 80, 90, 85, 95% done in terms of grading. So hopefully I'll have grades for you. Like, I want to try to have it done by Thursday, and then maybe I'll try handing them back in class. So that's kind of my goal there. But we're very close to done with them. ITP Spring 2020, and let's go with collats.py. All right, so the collats conject. So basically, let's see. So let's create so we're going to write a function today called called collats length of n, which given n tells me that will tell me how many numbers are in the collat sequence, if that makes any sense. Right, so let's go ahead and comment that. Okay, and I'm probably going to mess up while writing this at some point, but let's say we're given the number 5. 5 is odd, so it's tripled plus 1. 5 goes to 16, which goes to 8, which goes to 4, 2, 1. So that answer should be yielding, so that answer should yield 1, 2, 3, 4, 5, 6. Right? Makes sense? There's 6 numbers in that sequence. We start at 5, 6 numbers in that sequence. If I start at, sorry, was there an issue? Oh, yeah, that's just weird things that my font can do. So this is just simply equal then, like that. It's I use a font called Fura Code that has ligature support. The arrows are just simply this together. So let's take 3. 3 goes to 10. 10 goes to 5. Interestingly enough, I can just simply copy and paste the rest of this over here. And I can say that has a total of 1, 2, 3, 4, 5, 6, 7, 8 numbers in it. Well, keep this in mind for later, that basically once we hit something if we can hit something we've already calculated in the collat sequence, it will behave exactly the same way as we saw it earlier. So this is just simply 2 more than 5 because it took us 2 steps to get to 5. So, but we're not going to try to do anything clever like that right now. So while n is greater than, so what we're going to do is that we basically need to do a while loop because we've given a number, we don't know how many times we have to do this for this number. What we do know is the rule, which is, so let's say while, and we'll figure out the condition later. So I'm just going to go while, I'm going to say done is equal to false. While not done, and I'll replace that later. I just want to get coding. While not done, what am I going to do? I'm going to, if n is odd, sorry, if n is even, right, I have it. So n mod 2 equals 0, right? If the remainder of n after I divide by 2 is 0, then that's an even number. So in this case, now I need a half n. I'm not going to be losing anything or chopping anything off because it is divisible by 2. We've established that. It's an even number, so it's divisible by 2. Else, it's an odd number, so we can just we don't have to write an else if or anything. We can just say n is equal to n times n is equal to n times 3 plus 1. Okay, and now what we'll do is we will, let's see. Let's go ahead and print n over here. And if n we'll go ahead and print, actually I'll print it once outside of this loop so we can print it. And then we'll say, then we'll print it once we apply the operation and say if n is equal to 1, right? If we did our operation and we got n to 1, then we are definitely done, right? We stop when we hit 1, right? So this is probably not how I'll do it in the end, but it should work for right now for just simply printing out the numbers for it. So let's go ahead and call collat's length on let's test it on one of the ones we calculate ourselves, 3. So it does 3, 10, 5, and then 16, 8, 4, 2, 1. So that was 8 total steps. So that seems, so at least so we know this algorithm works. So let's go ahead and try on let's go ahead and try it on 5 and see what it prints out. And let's go ahead and try it on, let's go ahead and try it on something like 35 and see what happens. 35 gives me 106. And look how it basically got down, how basically it does a bunch of stuff and then hits 10. Oh, sorry, then hits 10, which we've seen before, which then goes to 5, and then we see the repeat of our sequence. Interesting, once we hit a power of 2, we basically start, what's interesting is once we hit a power of 2, it guarantees that it's going to go to 1 because you can keep dividing a power of 2 until it hits 1. So what we need to do now is, like, let's say, so let's go ahead and change this condition. While n is greater than 1. Let's try that one. We're going to do this. That way we can remove this over here. So that seems to work still. So while n is greater than 1, we do this. Now, the print statements may be confusing you because let's go ahead and see what happens if I remove those print statements and move this up. So 35, so 35, 106, 35. So we go down all the ones, and the only thing that happens is that once n is equal to 1, we stop and we don't print it out. That's okay, but it's just one of the things you'll need to keep aware of when you do while loops is like if I'm trying to print out information in it, or trying to get it to stop, will it stop before I actually do the thing that I want to do? Which is fine. Gets to the end. While n is greater than 1, mod 2, sorry, if it's divisible by 2, divide by 2, otherwise multiply it by 3, add 1. Okay, so now let's start counting the operations that we have. Let's say steps is equal to 0, and steps is either going to be equal to 0 or 1 depending on what our, so let's see, will it be equal to 0 or will it be equal to 1? Because that's the question about how many steps it will take. Again, this is why having a pre-solved solution is good. So let's go back to 5. And essentially what we're going to do is say, while it's greater than 1, do an operation and say steps is equal to steps plus 1. Make sense to everybody? So while this thing is greater than 1, if it's divisible by 2, divide it by 2. Otherwise, triple it and add 1. And then Once we do either of those, that's a step, so we'll do the step. And then what we want to do in the end is actually return steps. Now, print the collat's length, 5. So we know this is 6 steps, but really there's 5 transformations. See, 1, 2, 3, 4, 5. There's 5 transformations. And this gets into something we're going to be dealing with. I think I might make that the topic for today, the fence posting problem, which I'll get into more detail. But look at this. We're trying to count the number of numbers, but really what we counted was the number of sequences. So we're trying to count the number of items in the sequence, but what we counted was the number of transformations. 1, 2, 3, 4, 5. Right? The while loop, as it turns out, runs 5 times. Right? Because it doesn't run once it hits 1. That one's kind of a freebie. You get to 1, you stop. So the way we fix this is that, if it's off by 1, well, we just add 1. So now, collat's length 6, which is the appropriate amount. If we do 25, 25 goes to 50, goes to what, 76? Turns out 25 has 24 sequences, which is pretty cool. All right. So everybody see kind of how this while loop works? Any questions about this while loop? Now, what about if we wanted to print out the actual sequence itself? Well, in that case, we might want to start playing with a list. So steps. Let's go and say sequence is equal to an empty list, or sequence is equal to an empty list. And then to add something to a list, because unlike strings, these things are immutable, we use the word append. Sequence, and we're going to append n. And so now I'm going to do something a bit different. Rather than doing steps, right, we're starting with number over here. And then what we'll do is we'll do sequence. We'll generate the next number of the sequence, and then we'll append it to our list. So basically we start with 5, we calculate what the transformation of 5 to 16, and we add 16. Then we calculate the transformation of 16 to 8, and we add 8. Then we calculate the transformation of 8 to 4 and add 4, or append 4. And so here, what I'm going to do is that I'm going to go ahead and before I return something, I'm just going to go ahead and print this out. Print sequence. So that's a lot of numbers. I can't really tell you how many. If I don't want to tell you if there's 24 of them or not. So let's go to back to 5. We know that 5 produces 5, 16, 8, 4, 2, 1. Awesome. So we've added everything to there, and rather than counting, and what we could then do is that we could, if we want to return that information, we can return the steps and the sequence together, like this, right? Steps. Sorry, we can return sequence, comma, len sequence. Right? The sequence of numbers and how big it is. Notice it prints out this tuple, which again is like a list. It's just you can't change it. 5, 16, 8, 4, 2, 1. Right? That's those items over there. Except 6. Although, honestly, it's a bit of a pain to write, to look at that and see, you know, with the commas and all that. So I think I'll just separate it out. Sequence steps is equal to the class length. Print sequence, comma, has steps. right? Separating them by commas here. 5, 16, 8, 4, 2, 1 has 6 steps. Make Python do the work for you a lot of the time. It's nice. Now we can do something fun like this, and we can do something fun and maybe throw this in a for loop. No. For I in range 1, let's go with 100. Right, and then simply say collat's length of, well, let's do 1 to 100. Up to and including 100 means this step sequence. And so now, forgot my colon. And now we've got quite the mess, actually. So 1 has 1 step, 2 has 2 steps, 3 has 8 steps, 3, 10, 5, 16, 4 has 3 steps, 5, 17 steps. 9 surprisingly has 20 steps to get to the end. And notice as we get bigger, the amount, the length of some sequences become bigger. Look at this, 55 goes all the way up to 3644 before it can go down again. Oh, it goes up to 61. It goes up to 9232 actually, and then from there it's able to get enough halvings that it decreases. Right. So some of these have a really long amount of steps, which is kind of astounding. I think. So now what's fun about this problem is that it's basically still remained unsolved, even though it's very, very simple. Let's see. Numbers from 1 to 9999 to their corresponding stopping time. So if we look at this, we've got some numbers in the 9,000 range, which take over 250 steps over here to get to the end. It's a very interesting thing, and what's cool is, another cool thing is that you can kind of graph it out as like a flowchart, right? Here's a graph, right? We know that like 5 goes to 16, but 32 also goes to 16. 64 goes to 16, 21 goes to 64, right? 3 times 21 plus 1 will give us 63 plus 1, which gives us 64, right? So we see basically that we get this kind of flowchart where each number basically tacks on certain, where numbers basically generate sequences, and sequences don't really ever repeat except when you get down to 1. This forms what's called a directed acyclic graph, which you'll learn about whenever you learn graph theory. All right. So, yeah. Fence posting wasn't on my agenda today, so I'll skip it. What I want to do is get us working more and more with lists. So there was this nice exercise I saw on Runestone Academy, which is pretty nice. So how many of you know about Kiva? No? So Kiva is a micro-lending site. Essentially, they are a nonprofit that, think of it like, I think it came out before GoFundMe, but it's a lot like GoFundMe in the sense that basically you've got people who are asking for money. Let's go to agriculture, right? So, right, these are people asking for small loans, relatively small loans, from multiple people, and you can basically lend them money, and then they pay it back. And then the idea is that once you get paid, because these are these are loans, not like buying something on Kickstarter. It's a loan, so you get paid back, and then the idea is that once your money's in this infrastructure system, you actually go and relend that money. So I've got $25 I've loaned out, and that's being paid back, and then I'm going to relend it to somebody else. Right? It's kind of the way it works. You choose what it is. The default rate isn't that bad, but it's a way to, It's a cool way to help people. So to know whether or not something is working, you need to crunch the numbers. So we're going to learn a little about data science, which is looking at data and grabbing out, interesting statistics about it and trying to see what's interesting about the data. Let's look at what data science is, according to Wikipedia. Is an interdisciplinary field that uses scientific methods, processes, and algorithm system to extract knowledge and insights from structured and unstructured data. Unstructured data is hard to mess with, but this is structured data. In other words, stuff that's organized. Unstructured data is kind of the stuff like, I believe that if I'm recalling correctly, like structured data would be the stuff that would be things like, the information about a post on Twitter. Like when this person made it, who made it, what time they made it at, right? How many characters are in it. Whereas the unstructured data portion of that is what they actually wrote. Right? It's typically text heavy, but can hold dates, numbers, facts as well. Anyway, so humans generate and therefore a huge amount of data, and we collect huge amounts of data basically every day. Think about all the images that basically everybody takes and uploads, right? Think about how many pictures you take, then kind of multiply that by basically everybody who has a cell phone. Then think about the people on Instagram who basically do nothing but take photos. There's a lot of them. All right, so we generate a lot of data. So we're going to be looking at this table of data. And we're not really ready to start looking at how do we read files or something like that yet. I rather would, and that's part of the reason I like this. It allows us to work with a big data set, right? Has a lone ID. IDs are basically unique identifiers to look up something. Like, for instance, you don't typically use names as identifiers in computer programs because your name is not unique. Case in point, Andrew Rosen. Right? Let's see. Andrew Rosen is a pioneer in the contemporary fashion market. Ooh, right? Retail executive. Let's see. Steps down. Oh, hey, I'm on the first page. Woo! So, but there were other things there for me. Somebody in New York. There was also CEO of Kaplan was an Andrew Rosen. So yeah, and then let's see. I also went to school in my middle school, which was anyway, it was a small school, and somebody graduated from the 8th grade named Andrew Rosen the year before I entered 6th grade. So the school basically had 6 solid years of an Andrew Rosen there. They just happened to be 2 different people. Your names are not unique. Things that can be unique are like email addresses generally are pretty unique. It's why you typically have at a lot of online sites you'll log in using an email address. IDs, and where we can't really create that, will often generate an ID. Loan amount should be fairly straightforward. It's probably in dollars, but for the sake of analysis, we don't care. These could be in Canadian rubles or something. No laughs at that? Okay, tough crowd. Country name. Status. Time to raise. And then num lenders total. Notice that funded basically probably has only one of 2 values, either funded or unfunded. So Python's actually really awesome at using doing data analysis. For data analysis, there's pretty much 2 big programming languages that are used. R, which literally the letter R, the R programming language, it's made for data analysis, and then Python, because of course Python. They mentioned that this table is a random data set, and by the way, this is in your textbook if you want to follow along. They have 1.4 million rows as opposed to I guess this is maybe 30 or 50, just glancing at it. So to keep your coding easier and cleaner, they put it all into lists. And they're all listed here, but I can, and even though they're not listed in anything over here, I can still use them. Like over here, just simply to keep everything clean and easy to read. Like here, I'll kind of show you print loan amount, save and run, bam, I can still use it there, right? It's like variables like kind of already exist there. All right. So here we're keeping 4 things. We have 4 data things. Loan amount, country name, time it took to raise, and the number of people that lended. And we can kind of see that, let's see, length, loan amount, and length. Let's go ahead, and that's num lenders total. They should have the exact same. Oh, come on. Oh, right. Why isn't printing it anything out? Because I didn't tell it to print anything. I make that mistake all the time. I just happen to know how to fix it very quickly because that's one of the things I check for. Why am I not seeing anything? Did I actually print it out? So they have 25. Data points. So all the index zeros match. All the index ones go to each other, right? 500 El Salvador 1157 18, right? 500 El Salvador 157 18. So those all the indices go with each other. The zeros go with index zeros go with each other. Index ones go with each other. Index twos go with each other. So let's go ahead and look at some very basic things. And if you want to follow along, go to the Runestone Academy over here, right? You'll want to go to, let's see, all right, go to the class website. And then it's the Project 6, Computing Statistics with Kiva. All right, so let's take a look at our first questions. What is the total amount of money loaned? So we're going to do this first the easy way, and then we're going to do it the not the hard way, because it's actually also very easy, but the manual way. Okay, so loan amount contains all that money information, right? So, right, print loan amount, and I get all these things. So I want to know how big this is. It says we need a loan total variable. Oh, it's cool. It's telling us whether or not we were able to do, whether our tests are running or not. So loan total is equal to, so given a list, one of the cool things you can do in Python is just ask to sum it up. If it's a bunch of numbers, you can just simply say sum of the list, and it will add up all the numbers in the list for you automatically. Save and run. It says it wants us to use the accumulator pattern though, which we'll do ourselves, right? So this is one way to do it. Other programming languages aren't nice and don't always have some, but it's useful to know that that exists. To do it manually, we just use the accumulator pattern, say loan total is equal to 0 for num in the list, for each number in the list. For number in the list, num amount. This is the accumulator pattern we learned earlier. Loan total is equal to num or loan total plus num. And then, yep, they said you may not use sum, so that's good. So question 2, they have a lot of separate boxes for each of the questions, which is compute. So question 2 is, what is the average loan amount? Then 3, what is the largest and smallest loan amount? What country got the largest and smallest loan? What is the variance? Ooh. And what is the average number of days? Let's go ahead and see about the variance for a second. Does it have anything about the variance or no? Average number of lenders. Yeah. So we'll restate these questions to make them more precise. So, all right. The next one is compute the average amount of money loaned and stored in the variable loan average. Well, the average isn't too bad, right? Let's go ahead and grab the code we already have, right? The loan total is 0. We go through all the numbers in the loans and add them up, right? So to our loan total, we get the total amount of stuff we load. And the average is just simply take the total amount of loan money you have and divide it by the divide it by the number of loans you have, right? So loan average, and this is true for pretty much the average of anything, is equal to the total divided by the number of things you had. And I said it was 25, but I might not have a good memory, so I'll just simply have Python tell me how much it is. So the average was 663. So the average loan amount is $663. Let's see. So now this one, store the minimum loan in min loan and the maximum loan in max loan. Then store the name of the country that received the largest loan in max country and the smallest loan in min country. In min and max are functions that you can use to find the value of the minimum or maximum in a sequence. Oh, boo. That's just silly. Okay. So, what they're referring to here is two other things you can do with two functions that are built into Python. Let's create a list over here. 1, 4, 2, 93, negative 17, 12, 50, 4, 100. Okay, whatever. It doesn't matter the numbers you put in. If you throw anything into the max function, it'll give you the biggest thing there is in there. 100 is the biggest number. And unsurprisingly, throwing anything into any list into the min function gives you the smallest thing there is. There's other cool things we can do with lists. Pretty much anything, we can do that manually, and I'll show you how. Because, let's see, was it L dot index of index 4? Yep. So what's cool also in Python is you can use something called the index function. So L dot index, so list dot index gives you, and then so index of 100 gives me 8, which, like, what do 108 have to do with each other? Well, index 0, 1, 2, 3, 4, 5, 6, 7, 8. It's the index gives you the first index it will find it at. So if I ask for index of 2, it'll give me 2 because 2 occurs at index 2. If I ask for index 12, it'll give me 5, 0, 1, 2, 3, 4, 5. So that 12 is in index 5. So it's a useful function to be able to find where something is. Okay. So there's a bunch of ways we can do this. It's pretty useful, yeah. So using these functions, we can either write this manually, or we can write this using the functions built into Python. So I'm going to first write it with the functions built into Python. So let's go ahead and find the smallest loan value, which is min loan. And we're just going to get that out by asking for min loan is equal to the min of loan amount. And I think this will come as no surprise for everybody else that max loan is equal to max loan amount, right? No surprises there. So the trick is, how do you find out what the countries are, right? Well, we got the loan amount. So print min loan and print max loan. You don't really have to print these guys out. I'm just going to run them though. So the smallest loan was 100 and the biggest loan was 1,800. Now the question is, print, let's see what variables there are. Again, I think it's countries. Country name. There we go. How do we know which of these countries had 100 at the same index of it and 1,800 at the same index of it? Well, we just look for the index of where 100 occurred, and that will correspond with the one in this list, because all this list is just this country name has been has been put into one list, the loan amount has been put into another. So if we search for the smallest amount, 100, that should give us, that's its index 0, 1, 2, 3, 4, 5. Index 5 should give us the Philippines. So 0, 1, 2, 3, 4, 5. So it does. But I don't want to have to do that, myself. So what we'll do is we'll use the index function. So index, so let's go ahead and say min index is equal to loan amount dot index of the min loan. So give me the index of that corresponds to the minimum loan. And if you're thinking that the next line is going to be the same thing but with min changed to max, you're exactly right. So now we can print min index max index, print those out. So we got 5 and 16. So now we have to define our min country and max country. So min country is equal to country name. That's the list with all the country names in it. Min index. And then, again, just change this to max. So, all right. Again, I'm just going to explain this again. Use these functions, figure out what the smallest and the biggest thing are. Get the index of the smallest and biggest thing, and get the name at the corresponding index for each of those things. Philippines and Georgia. So, there is a way where we can do this manually. So I'll just simply grab this, where we sort this thing out, where we find these values manually. So let's say the minimum loan, we want to choose a reasonable value. So the smallest loan is probably going to be more than $0. And the biggest, the minimum loan is probably going to be smaller than $1 million. Or whatever this number is, right? The maximum loan is probably going to be bigger than $0, right? And then we're just going to assume that the min index 0, max index is 0. Actually, You probably didn't follow the logic of that, so I'm going to just change it up slightly. We're going to say that the smallest loan amount is loan amount 0. So we're going to assume the first thing, so this is again doing it manually. We're going to assume that the very first thing in the list is the smallest loan amount. We're also going to assume that the very first thing in the list is the maximum loan amount, is the biggest thing in the list. Now why? Because those will change very quickly, but we are at least initializing our values and we have something to compare numbers to. Right? And the plan is what we're going to do is that we're going to look at all the values in the list. And when we find something bigger, we found the new biggest thing. And when we find something smaller, we found the new smallest amount. So it's a rather simple loop, and one you'll find yourself using quite a bit. For num in loan amount, if number is greater than the max loan, so if that number is bigger than the max loan, then congratulations, that number is now the new maximum loan amount, right? If the number we've seen is bigger than the biggest thing we've seen so far, then that is the new biggest thing we've seen so far. If number is smaller, we can do an else if there if we wanted to, but it doesn't hurt us to do an if statement. But I'll go ahead and do an else if. Else if that number is smaller than the smallest thing, right? That number is smaller than the smallest thing we've seen so far. Congratulations, you found the new minimum. Right? And also, we're going to, while we do this, I got to go up with one line. If we found the new place to put the max loan, we'll say max index. Ooh. Forgot about that in Python. It's not an issue in other programming languages, but Python is a for each loop, which means it doesn't really care about what index it finds stuff at, right? It just kind of just zips through it. So right here I'm going to use a special, so I'm going to show you how to use a special word here. Showing you all sorts of stuff today. Okay, Python 3. So let's create a list over here. L is equal to, I'm going to do a list of strings because I'm about to combine words with numbers, and I don't want to mess up words. And I don't want, if you have numbers and numbers, you can sometimes confuse the indices and stuff. So let's go and do apple, banana, cucumber, durian, eggplant, all right, so L gives us those things. So now for fruit, so we've learned about two ways to go about this. Iterate over this, by the way. For fruit in L, print fruit, right, which will print out all the fruits. Or for index in range, you got this thing, which honestly is ugly. For index in range, length of L, print index L index, where we have the index, and then we can use the index to get the item out, right? 0, 1, 2, 3, 4. The thing at index 0 is apple. The thing at index 1 is banana. 2 is cucumber. 3. This look familiar to everybody? And also ugly, right? Okay. It was an Okay. So I'm going to show you how to do something significantly less ugly. For x comma, so let's see, for, I think it's index fruit in enumerate L. Print index comma fruit. So notice that I've got two values for blank comma blank in enumerate this. This is actually a really cool thing. It allows you to go over both the index and the item in it at the same time. So I need to start out by saying that this is never a required, this is not like required. Like you can program just fine if this didn't exist or you didn't know it existed, right? Because this output is the exact same as this output, right? This is just one of those things that Python likes to do to make it easier, enumerate. So we enumerate over all the options. We give ourselves both the index and the item. Sorry, the index and the item. So we can say for index num in enumerate loan amount over here. We can then just simply worry, we don't have to worry about grabbing any index, but if we care about the index, like we can go through it normally not caring about the index, but as soon as we might care about it, right, we can do that. So here we're saying, hey, if the biggest thing, if the thing we found is bigger than the biggest thing, that thing is the new biggest thing. By the way, I'm going to keep track of where I found the new biggest thing. Make sense? If the thing I found is smaller than the smallest thing I found so far, well, that thing's the new smallest thing, and I better keep track of where I found that new smallest thing. It's amazing how evocative new thing can be. So, and save and run, and it still works just fine. We get Philippines and Georgia still. Compute the average number of lenders per loan and store it in variable average lenders? Don't we already know that, or no? Num lenders total. Num lenders total. Num lenders per loan. Oh, the average number of lenders per loan. Not like the average. So, in other words, the average of this list. I thought it was asking for something to deal with, like the loan amount and that relationship. No, it's a lot easier. Compute the average number of lenders per loan and store it in the variable average lenders. Okay, let's go ahead and they want an average lenders. Average lenders is equal to 0. Run. Very similar to, you may not use sum. Ger arg. So for num in range, and then I've got to scroll up here because I'm trying to figure out what it is. Num lenders total. So for num range, so actually I don't need the range. For number and the number of lenders total. Average. So we want to figure out what the total numbers is. So total is equal to 0. Total is equal to num plus, total is equal to total plus number. Right, so we accumulate it, we add all the things to the total, and then we just can simply say average lenders is equal to total divided by length num lenders total. So right, we add up all the numbers in the list and we divide by the number of things in the list, and that gives us the average. Pretty much exactly the same as the second one we saw. Let's see. So there's a number of interesting So a lot of the statistics we are calculating, we can calculate the total number of loans made to the Philippines. We can calculate, how much the average amount of time to the time dollar that it takes to fund a loan. What is the country with the loan that takes the longest to raise? All right, so there's all sorts of questions there. So let's say for the next 20 minutes that remain in class, you guys work on, let's say for the next 5 minutes you work on this problem and the next problem. If you don't have your computer with you, just sidle up to somebody who does. Yes? Excellent question. If you have, he was asking, if you've got a list like this, 12, 5, 2, 5, 7, and we're asking for the index of 5, what gets returned? Because there's 2 5s, right? And the answer is that you get the very first one. Another question that I should, and in a similar vein, what if you ask for the index of something that doesn't exist? You get an error. It just crashes on you. All right, any other questions? Because I want to give you some time to exercise, so to speak, on this. So work on the next two. Compute the total number of loans made to the Philippines and store it in a variable called Philippines count. If you, so right over here, we can just do Philippines count is equal to 0, run it, and then you should be able to figure out how to, and you should be able to count those things. Now it says it's looking for a list method to do it, so list Python. So I'll just leave this up here. All you guys work on it. And then, so while you guys work on it, if you don't have a laptop, just make friends with somebody who does. And we aren't going to turn anything in today. We'll continue on this on Thursday, but you'll want to have this stuff already. Yes. For the Philippines and the next one. The one that comes after that, which would be do number of loans made in the Philippines and the number, and then being able to count the number of ones that work in that country. Let's see actually over here. Unique country. Ah, there we go. For the second problem, you'll want to got all the countries, so you want a list to append all the counts to. Yes. 1 second. They close it? Sorry. Easier than it seemed? Make Python do the work for you. So hopefully you've tackled that first one right now. If you haven't, take your time. But what you want to do for the second one is use that answer. And for each unique country name, print a line that shows the name of the country and then the number of the loans made in that country, like this, Guatemala 1. So you'll want to use what you did here and generalize it for out, right? And generalize what you did, right? And do it for each country. So this is just simply a more involved version of the second problem is a more involved version of the first one. And again, let Python do the work for you using list.count. All right. So, is anybody who's done with the second one? Smattering of people. Okay. Cool. So, all right. So we'll work on this one, and then let's see. So keep working on the second one. I'm going to go ahead and open up. Actually, I'll open up a Canvas Dropbox for this, so you can turn in what you have for credit today. If you don't have a laptop, just have your buddy email it to you. Yeah, just turn it in like by today or something, or whatnot. Like by the end of today, I mean like midnight tonight. Turn in what you have, like just copy paste it, you know? So here, I'll show you what to do. Look, boom, assignments, boom. Okay, new assignment, create new, 225, project stuff. This will go into quiz in-class assignment. It's worth, let's say, 7 points today, because why not? Display as points. File uploads, and you can either upload a file or you can copy paste it as a text entry. I've checked the text entry box. That will be easier. Don't care about plagiarism review because it's code, so the plagiarism review will kind of go haywire if we check that. And it'll be under quizzes and in-class assignments. Okay? Yes? Copy paste what you have for this part. The unique, so the second one. So you have Philippines counts, and then the counts for all the countries. And by the way, if you're getting issues like with 2525 like I am, which might prevent you from printing it out correctly, it's because all the way up here I printed out 2525. So, and that apparently gets loaded into every text box. So if that's your issue, just delete that. Whoops. On Canvas, 225 project stuff. If you don't have a computer, just have your friend email it to you. Or, go home and do it yourself later. All right. If you're done with it, by the way, you're dismissed. Or if you're fed up, you're dismissed. So